All right, everybody, welcome. My name is David Eustis. I'm a software engineer on Google Cloud. I'm here with my colleagues Ken Owens and Conrad DeLong. And the topic for the talk today is about developing applications on Kubernetes. So first off, by a show of hands, who here has heard of Kubernetes? That's good, yeah, because the word has probably been mentioned a few times at this conference. All right, hands up again if you've at least played around with Kubernetes, maybe taken a tutorial. All right. How about if you're using Kubernetes on a daily basis? Great. So we got the whole range here today. We are going to be covering some of the basic building blocks of developing applications on Kubernetes, but there should also be some new information for everyone about how to take advantage of the new application resource that we've been working on to think about applications as a more holistic unit in Kubernetes. So with Kubernetes, you can manage computing resources. So that's about scheduling containers onto a cluster of servers. But I think one of the reasons that Kubernetes has been so successful is it doesn't just do that. It also helps you manage other types of infrastructure, specifically networking and storage. So if you're building any or most kinds of real-world applications, you need to configure some amount of networking. For example, configuring service discovery so that as your containers are moving around in the cluster, they can find each other, or load balancers or firewall rules. On the storage side, this is about where your application data lives at rest. For performance reasons, you might want that storage in a locally attached SSD, or you might want it on a network-attached file system so that it can be more dynamically accessed. So you need to be thinking about all these things when you're developing applications for the cloud, and Kubernetes has a really nice construct for doing this, which we call infrastructure as code. In this example, there's a resource here called a pod. If you're not familiar with that, that's OK. The important thing is this is a simple configuration file, and it lives in source code. And so it's in source code along with all the other application code that you're developing for your application. And that means you can use all of your existing source control tools for revision control and code review and release. And that's really great from a management perspective. And if you need to be controlling network and storage infrastructure at the same time, that's just more of these configuration files. And then when you're ready, when you want to push an instance of your application to Kubernetes, you just upload the config to Kubernetes, and it's going to manage the underlying infrastructure for you. So these configs are in the language of Kubernetes, and Kubernetes knows how to manage underlying infrastructure wherever that might be on Google Cloud or on-prem or somewhere else. And so that means as an application developer, you don't actually have to think about where your application is going to be running in production. You can just target Kubernetes. So what about deploying a whole application? What does that look like? So these days, there are actually some pretty nice tools in the ecosystem for this. Helm is one such tool. And the Helm community has done a really great job of packaging up many common open source software stacks that you might want to be using on Kubernetes. So with a command like this, these days, once you set up your cluster and set up Helm and maybe a few other things, you actually can install WordPress with a single command like this, which feels pretty good, or I thought this was pretty cool when I first saw it. But then what you end up with is a little bit intimidating, especially if you're new to Kubernetes or you're installing an off-the-shelf app and you don't really know how it's all put together. And what you're seeing here is basically the list of resources. And these are the resources we need to configure all that infrastructure. But at this point in my journey of using this application, I probably don't need to see all of this. And something seems to be missing here. Basically, where's WordPress is the problem. And what I mean by that specifically, if I just ran this command a second ago, chances are it's not ready yet. There's some sort of installation progress that needs to happen. Even in the cloud, provisioning this infrastructure takes time. And we do have that list of resources, so what's their status? Once the thing is up and running, you need to connect to it. So if it's a web hosting application, that might mean connecting to a URL for the site or the admin console. If it's a backend service, you need a quick link to the service endpoint, the credentials, maybe some client commands or tools for smoke testing the application. And then that's really where the process just begins, because now you need to customize the application for your use case. And for that, you probably need a link to the user guide, maybe some quick instructions for the most common operational tasks like performing upgrades, backups, restore, or deletion. So that's the general problem that we're trying to tackle with the application resource. And for that, so just a quick note on the agenda. So we're going to introduce the Kubernetes application resource. We're going to talk about how we've been integrating applications into Google Kubernetes Engine, which is Google's hosted Kubernetes offering. And we're also going to talk about how you can get started with these apps quickly in the Google Cloud Platform Marketplace. So I will hand it over to Ken Owens.
Thanks, David. Hi, I'm Ken Owens. I'm a software engineer on Google Kubernetes Engine. I work on the Workloads team, and in the open source community, I'm a contributor and co-chair of Kubernetes SIG applications. So as a contributor to SIG applications, obviously I spend a lot of my time thinking about apps. So to start with, I want to talk about some of the things that go into applications. And from a show of hands, most of you are familiar with Kubernetes. Some of you, can I see how many people are using it in production right now? Substantial fraction. So some of this might be a little bit of overview, but for some of you, this kind of is necessary to understand what's going on with the demo later. So a pod is basically an atom of scheduling. It's a set of containers, some volumes, and the compute resources, mem, CPU, that go along with that. Kubernetes is a declarative API. So when you create a pod, you specify those things, and the system goes ahead and makes sure that pod gets scheduled and created as you specified it. Oop. There we go. So volumes. Volumes are how your pods, if they have durable storage, write things to disk. They mount inside of the container, and it just appears in the file system. Now, if you want it to be durable, if it's not an empty dir, if you don't want it to disappear, then you need to have a PV. PV is a persistent volume. On Google Cloud, that's backed by Google Persistent Disk. PVs don't disappear with a pod. If you want to schedule a PV, if you want to actually provision one and mount it into a pod, use a persistent volume claim. And all that's well and good, but ultimately, even if you've got your compute, if you've got your storage, if you've got your mem and your CPU, you need to get network traffic to the pod. In order to do that, you use a service. This is basically your atom of networking. So a service basically just programs a network to route traffic to a pod. And if you want to expose it externally, you can do that on our cloud. That'll provision a load balancer for you. So those basic core resources are like the primitives that you use to turn up a workload on Kubernetes. But they're not really interesting. I mean, most workloads don't consist of a single pod. And most people don't want to go through the exercise of managing pods individually. That's where the Workloads APIs come in. So the most basic, and it's not really that basic anymore, resource for scheduling many pods are deployments and replica sets. Now these are for your stateless 12-factor applications. When you create it, again, it's a declarative API. You create a deployment. You say, I want N pods, and I want them to have this container. I want them to have this many resources. The system's going to go ahead and schedule those pods for you. Now, it can roll them out concurrently, meaning if you create like 5 pods, you may get 2 created at a time. If you scale that down, if you say, you know what, I don't want 5 pods anymore, I'd like 3 pods. It may kill 2 of them simultaneously. And that's fairly desirable. You want to be able to accelerate rollouts for stateless serving applications, but not so much for databases. And that's where stateful sets come in. So stateful sets are an attempt to help you build applications, run workloads that contain things like databases or other distributed storage systems or other distributed systems in general, message queues, Kafka, whatever you like. And we found that they required some additional semantics around them. So for stateful sets, it'll do rollouts as well, but it rolls them out one at a time, meaning that when you get pod 1, pod 2 doesn't come up until pod 1 says, okay, I'm ready, you can put traffic on me. When you tear it down, You don't tear down pod 1 until pod 2 says, okay, I'm done. Whatever I had to do to clean up, it's happened. You can take me down. You can move on to my next guy. And other than that, the pods also have durable provision storage and a durable network identity. And what that means is, let's say a pod dies. When the pod comes back, it's going to have the same network identity that it had before. And that's in terms of DNS. The IP address may change. But again, using DNS, it's generally enough to be able to identify that pod directly. More importantly, potentially, it's going to have the same storage. So if you wrote something to a disk, pod 1's disk, when it comes back, is going to be the same disk, and it'll be able to retrieve its storage. And lastly, you've got daemon sets. So some very complicated apps, like, say, distributed file systems, might want to do something like deploy a pod to every node in the cluster. So if you're familiar with HDFS and you're deploying like a data node, you want to select a subset of nodes and say, I want a data node on all of these. It's kind of a different paradigm from just replication, which is what deployments and stateful sets are good at. And daemon sets are good for that. So now we've talked about all these resources, but David kind of made it very explicit before. This is kind of hard to manage. Like, you take all of these things and plug them together, and at the end of the day, it's really kind of hard to have a unified view of what your application actually is. Moreover, all of the tools in the ecosystem kind of have a slightly different definition of an application. So in SIG apps, what we set out to do, sorry, I missed this. Config maps and secrets are also something you see commonly. They're just basically storage for your configuration values, map of keys to a map of values. And the difference between config maps and secrets is primarily that secrets are encrypted. And you also might see some ingresses layer. Ingresses effectively route traffic into the cluster, and they're used for firewall rules. They'll do TLS termination, and they work at layer 7. So back to what I was saying before. So in SIG apps, we started thinking about, well, how can we defragment this? How can we make sure that KSonnet and Helm both look at an app the same way, and that the GKE UI and the Tectonic UI and the OpenShift UI all start looking at an app in the same way? So all the resources that we talked about before, they're nothing special, right? They ship with Kubernetes by default. But Kubernetes provides you a mechanism to extend the API to have your own resources. And those resources aren't any different in any meaningful way from the resources that we ship with a distribution. So SIG apps sat around and say, okay, well, let's come up with a resource that represents an application. Let's figure out what that looks like, and let's do it with the consensus of the community so that we don't have 20 of them. We have one. Now, we're not going to ship it by default with Kubernetes, but anybody who wants to use it, and primarily in SIG apps, we have a lot of tool vendors, tool builders, and UI designers, they'll be able to use it, and we don't have to reinvent the wheel from scratch every time. So it should promote interoperability and reduce the level of effort that developers have to put into thinking about this. So what it really does is it just groups resources, describes the application, and provides a set of properties about the application that are configurable on a per instance basis. So the resource metadata is just the same metadata that you see with every Kubernetes object. Pods have them, stateful sets have them. It basically just identifies the metadata of the application itself and of that instance. So the descriptor. Now the descriptor groups information about the application kind, I guess you would say, right? So let's say you have a MySQL application. The descriptor for MySQL probably isn't going to change much. It contains things like links to documentation, the maintainers of the application, or the maintainers of the underlying code, some notes about the application. Then we have info items. So info items are individual to a specific instance of the application. So this has things like the administrative password for the app, a reference to secrets, which is the same thing, IP addresses, credentials, endpoints, and other config values that are specific to an instance of the application. And lastly, this is kind of the magic part, is the grouping of the individual resources. So what this is actually saying is, okay, I produce stateful sets. That combined with the label selector that's in the application allows any UI, any tool, to be able to go find all the things that are in that application. And you'll see this in the demo that's coming up next. It allows you to build UIs consistently and allows anyone to build UIs that are able to discover all of the things that are in an application and present it to you in a way that's meaningful and application specific. And next we've got a demo from my colleague Conrad.
Thank you, Ken. Hello, my name is Conrad DeLong. I'm a software engineer on Google Cloud. I work on the Cloud Console team, and I'm going to tell you about how we are making use of the application resource in Google Kubernetes Engine. So if you are not familiar with Google Kubernetes Engine, let me quickly go over that. It's a hosted Kubernetes solution by Google. It's the most mature hosted Kubernetes solution out there. It's been GA for several years now. It fully manages your clusters, and that includes both the control plane as well as the nodes. It offers additional features like logging, monitoring, audit logging, and it comes with a very nice built-in UI, which I'm going to show you in a minute. So in this demo, I will first introduce an example application. Then I will walk over all the resources that this application consists of, and then I will show how using the application resource brings them all together. So let's jump to the demo. Can we switch to the demo, please? So what you see in this page is a list of all the workloads running in my Kubernetes fleet. And under the name column, you'll be able to find the front end and the two elements of the Redis. Actually, let's switch back to the slides for a moment. Yeah, before I show you the demo, I want to talk more about the app first. So the app consists of two components: the front end, which is a PHP application, and the back end, which is the database, which is Redis. And the Redis itself, it is split into two parts on its own. There's the Redis master and the data holding Redis replicas. Each of those is potentially replicated. So you'll see there are 3 replicas for the front end. There are 2 replicas for the data holding Redis replicas, and there's a single Redis master. All of that is exposed to the public internet using servers of a kind, load balancer. So in this chart, every rectangle corresponds to a Kubernetes pod. Every column of rectangles corresponds to Kubernetes deployments. And these fanning out connections are Kubernetes services. So if we use an application and just send it to our Kubernetes API plane, we'll be able to manifest the information that all of these resources belong together and have it all show them for us. So now let's switch to the demo. So the front end and the 2 Redises that I talked about, you can see them here. They're in the under the name column, you'll see the front end and the 2 Redises. Under the pods column, you'll see the number of replicas. So you'll see that there's 3, 1, and 2 respectively. And the same goes for the services list. You can see the front end is the only one that's exposed to the public internet. So I can actually go and visit that IP address. And there are 2 Redises living there. Apart from that, there's also a piece of configuration. It is a secret called MySecret, which holds the credentials needed to connect to the Redis database. So now let's have a look at the application's dashboard. So in this page, you can see the list of all the applications running in my fleet, all 1 of them. And you can already see that there is some information useful for humans to understand what's going on. So there's things like name of the software and version of the software. It is not used by any machines. It is for you to understand what's going on. And if we open it, we will see all of these components that we had to hunt for before. They're listed right there. On the right-hand side, you will see the description, instructions for what to do after the installation, and links to the documentation. And over Around the middle, in the info box, you will find the structured information regarding this specific instance of the application. So you'll be able to reach out to that service again. And you can even type something here. And you can also access the secret data that you have stored somewhere else. And again, this is just like any other Kubernetes resource. So if we open, so we can preview its YAML, and it's all right there. It holds all the information needed to render this page. OK, back to the slides, please. Thank you. So David mentioned Helm before, and you might be wondering how this relates with Helm. And the answer is it's fully compatible. It is just another Kubernetes resource kind. So if we want to make use of it, we just extend our Helm chart. This is an example list file for an example Helm chart with a template for generating applications. And then the installation changes from this to that. And you will just notice that there is this new application resource getting deployed. So after you run this, you will get this useful overview of your application for your own applications just like that. So if you are the only author of your application and you have like 2 workloads running there, this is a nice to have really. But it really comes handy when there are several teams in your company and you want to pass information between each other. And it becomes really critical when your applications come from third party. So to tell you more about that, I'll pass the mic back to David, who will tell you about Google Cloud Marketplace.
Thanks, Conrad. So yeah, now that we've seen a little bit about the building blocks of applications and the new application resource and its capabilities, I want to show you what's probably the quickest way to get started with applications using the Google Cloud Platform Marketplace. If you're not familiar with the GCP Marketplace, this is a product that's actually been around for several years. It was formerly called Cloud Launcher. And what you'll find there is a catalog with literally hundreds of solutions for whatever kind of problem you're trying to solve on GCP. All of these solutions have been vetted and tested by us, and we've made a strong effort to make sure you can get started with these quickly, usually just with a few clicks through the console. Some of these solutions are built by Google. Those are usually kind of the open source stacks that are really popular, and we just want GCP customers have a great experience using those. But actually, the majority of these solutions come from our third-party partners. And we have contracts with all of these partners to provide long-term maintenance and support of these solutions. So again, if you're finding solutions in the marketplace, you're going to have a good time using those. Traditionally, we've mostly had 2 types of products in the marketplace. One based on virtual machines, so partners provide virtual machine images, deployment manager configurations, if you're familiar with that. We also have some managed services in the marketplace. But we're excited to have announced just this past week that we're adding first-class support for Kubernetes in the marketplace. And we're actually the first public cloud marketplace to have this capability. But backing up for a second, why would we do this in Marketplace? I mean, we already have all these hundreds of virtual machine solutions, and they work great. But we actually think there's some reasons that containers in Kubernetes are a better way to distribute software, especially packaged software and commercial software. So if you're a software vendor out there in the audience or an enterprise consuming commercial software, this part's for you. And take notice, because I think this is going to be an important trend. So first of all, we all know that containers are portable. So if you find a virtual machine image from our marketplace, and then you try and install it on-prem, you're probably going to have a hard time with that. But that's exactly what containers would allow you to do. And similarly for Kubernetes, like I mentioned, when you're building an application for Kubernetes, you don't need to worry necessarily about where that infrastructure, where the application is going to be running at the end of the day. So that's also portable. So if you think about that for a moment, that means if you find one of these solutions in the marketplace, you can deploy it onto Google Cloud, but you can also take those exact same assets and deploy it onto Kubernetes, wherever Kubernetes is running. Containers are also much lighter weight than virtual machines. So a typical container image might be a few megabytes. For virtual machines, that's like gigabytes, and this makes a big difference when you're trying to rapidly scale up, scale down to respond to traffic. It's also great from the commercial vendor's perspective because what they're shipping to the customer is really just their own application binary. It's immediate runtime dependencies, not the whole operating system. And that's also great for marketplace customers because they probably don't want that operating system in their production fleet. They want to be using their own golden vetted host operating system that their IT department has given them. And then, of course, we've seen with all these great primitives in Kubernetes that containers have a lot of built-in management functionality for scaling, for rollouts, for failure recovery. It's just much easier to manage lots of these containers with Kubernetes than it is to do the same thing with virtual machines. And since this is a marketplace and we do have enterprise-grade commercial solutions, I want to mention that some of these Kubernetes applications have integrated billing. So what does that mean? First of all, it's pay-as-you-go pricing, which is what you'd be familiar with in the cloud. That just means the more you use something, the more you pay. If you shut it down entirely, you're not going to pay anything anymore. You're going to get one bill from Google. So as an enterprise customer, you don't need to have a commercial enterprise agreement with each of these vendors. We've done that work for you, and the fees will just show up on your Google Cloud Platform bill. One thing that we've done that's really interesting with these applications is we're able to support custom pricing metrics. So that means the pricing for the application is really tailored to the application. So for example, if it's a database application, the pricing might be based on storage. Or if it's a CI/CD application, the pricing might be based on the number of builds or the number of deployments. And this works a lot better than kind of trying to squeeze all of these commercial applications into a one-size-fits-all billing metric like core hours, which was what we've traditionally used for virtual machines. And then importantly, because we want all of this to be portable, the metering system that we've designed for this is cloud agnostic, and that means the metering will happen whether the containers are running on GCP or whether they're running somewhere else. To show you a little bit how that works, essentially, the applications themselves are generating billing metrics. They're reporting those metrics to a Google-managed reporting endpoint and identifying the customer billing account when they make those reports. And so then at the end of the month, Google tallies up all the usage, bills the customer, pays the vendor, and that's pretty much how it works. So we're really excited to have some of the top-tier third-party software vendors working with us for the introduction of these commercial Kubernetes applications. Some of these names you should be familiar with. You can see that this really spans a wide range of computing categories, from databases to security applications, CI/CD, logging, monitoring. I think this is kind of a testament to the power of Kubernetes itself to be able to support all these different types of distributed workloads. And we're really excited to have seen all the excitement from these vendors. I think they've understood the kind of new wave of containers in Kubernetes for commercial software distribution, and it's come through here. So thanks to all of our partners. So I'm going to jump over to a demo real quick. Just show you how easy it is to actually use these from the console. So here I am in the Google Cloud Platform console UI. We're in the Kubernetes section. I have a couple of clusters running here, but not much else is running in this cluster. So I'll go over to the applications section that Conrad was showing you and click Deploy from Marketplace. And so right away, I've got a catalog here with currently 27 solutions. That'll be growing all the time. Different computing categories are available here. If I open one of these, for example, Aerospike. Aerospike is a Flash-optimized NoSQL database. You can see, in this case, I've already purchased a plan. The pricing is based on storage hours. Whoops. Oh. Thank you. But I won't deploy Aerospike right now. Let's go take a look. We've got some other great solutions here from Aqua. This is a security application. They have a couple different pricing metrics based on the size of the nodes that are being monitored for this security application. But I think I will deploy an instance of RabbitMQ. So that's a distributed message queue system. This one happens to be packaged by Google, and so it's free to use. You just pay for your usage of Kubernetes. We have, let's see. So if I go to configure this, so right now it's got my one of my clusters selected. I could switch to a different cluster if I wanted to, but I'll just keep the defaults here. There's some custom properties that I could configure. So if I want more replicas of RabbitMQ, I could change this. If I want to change the default username, I could change that too. There's some quick links to the user guide tutorials here. But let's just go ahead and deploy this. So what's happening here is we're essentially pushing that configuration to the Kubernetes API, the same way you would do it with the command line tool like Helm. At this point, the application is all the resources have been created in Kubernetes, and it's just waiting for a few pods to be created. So I'm going to go ahead and shortcut this and jump over to the in-progress installation here. So we can see some components are still pending, but actually it's just waiting for a few pods to be created in the stateful set. So things should be like more or less working now already. So just to show you what we have here, so there's no external IP address for this RabbitMQ cluster. And that's probably a good idea. You don't want to be exposing your backend services to the internet if you don't have to. But just to show you that this is working, we can do a quick little port forwarding here, assuming this works. So here's the service where the admin console is being exposed. This is a neat trick in the console. You can actually set up port forwarding from your browser to an IP address inside the cluster. OK. Cross your fingers here. All right, so that's the admin console. But wait, I don't have the username and password. But thankfully, I just go back to the application resource and find them easily here. So the username is rabbit, and the password here is gibberish. We generated that so that it would be secure out of the box. And I don't know why it's saying that, because the login actually succeeded. And here are all the nodes. And there's nothing running in the queue, but there you have it. All right, let's switch back to the slides now. So at this point, we're just going to take questions. If I could invite Ken and Conrad back onto the stage.